I'd like to welcome everyone to this brief discussion with Dr. Robert Monticello about organofunctional silanes, antimicrobials in general, and metal-free antimicrobials as well. Dr. Monticello, can you briefly describe what a antimicrobial actually is?
Antimicrobials, in the most generic sense, is a term that reflects to any technology that acts against microscopic organisms to either kill or limit the growth. These can include viruses as well as organisms such as bacteria or fungi or algae. But really, terms that refer to any specific groups of organisms tend to be more useful, since they better reflect the intent and activity of the treatment applied to the consumer products, such as antiviral or antibacterial or antifungal. But we've generally thought of antimicrobial agents to be antibiotics that we take when we're sick because we have an infection. But these can also be chemicals such as bleach or alcohol, in addition to certain physical stresses like heat or UV radiation. But antimicrobial agents added in the textiles serve a really different purpose. As opposed to disinfecting contaminated surfaces, we're actually adding the antimicrobial to a textile to prevent the growth and prevent potential odors and degradation of the fabric.
Thank you. Also, can these antimicrobial agents also be antiviral agents?
Yeah, absolutely. Antimicrobial agents, they may demonstrate antiviral properties, but this is clearly a different category of performance. There's still a lot of discussion on the utility of treated textile surfaces with antiviral agents to prevent the spread of SARS-CoV-2 virus, which is responsible for COVID. Of course, in most cases, viral particles are not stable for long durations on these textile surfaces. And the stated intention of treating these surfaces with antiviral agents is to reduce the amount of time that infectious agents may exist on the surface. For example, from 8 hours in the absence of the treatment to 1 hour with the treatment. Testing for the effectiveness of antiviral treated textiles has been a real significant challenge, and currently the typical method that we're using for measuring this performance is a ISO test, ISO 18184 test method. But this test method does not specifically measure the activity of SARS-CoV-2, and in some cases doesn't really reflect the end-use scenarios that we'd expect on these contaminated textiles. The ASTM E3515 Committee on Antimicrobial Agents is currently writing a new standard specifically measuring the antiviral properties of treated textiles, really in an attempt to simulate the use or in the simulate contamination of due to SARS-CoV-2 surrogates. And this has been a significant challenge, as you can imagine. We do expect to have that methodology out within ASTM within a year or so.
I appreciate those insights. What are the advantages of metal-free antimicrobial agents?
To address this question, it's important to first identify the different types of antimicrobial technologies that may be out there. There are several types of antimicrobial technologies that are used to control the growth of odor-causing bacteria, and all of these types of products control some sort of bacterial growth, but they do it in a slightly different mechanism overall. And they will prevent the bacterial growth that will in turn control the odors that are released for them. In addition to how they work on the bacteria, these antimicrobials can also be grouped according to whether they can come off a treated surface to control the bacterial growth, or whether they affix to the surface and control bacteria growth upon contact. Technologies based on active metal ions, like ions such as silver or copper or zinc, they have to come off the surface in order to kill the bacteria or control the growth. Additionally, the carriers used to carry those active ingredients on the surface, they must specifically bind to the surface and must be done perfectly in order to make sure that there isn't any accidental release of those active ingredients. Metal-free technologies don't have this type of active ingredient that must come off the surface in order to perform. We must always be concerned about not only these technologies affecting our fabrics, but how these technologies can affect the environment around us. It's critical that we understand and control the release of these active ingredients into the environment. Since metal technologies must be released from the surface in order to control bacterial growth, their eventual environmental exposure is inevitable.
What are the advantages of organofunctional silanes as antimicrobial agents?
Yeah, we can say that they are biostatic. Biostatic really means whether we're killing the bacteria or whether the bacteria are just not able to grow. There's a big difference. There's a big difference about whether you're going to kill the bacteria or whether you're going to provide a surface in which they cannot grow, make it inhospitable for that growth. Silanes, quaternary silanes, organofunctional silanes, they're unique in that the technology itself binds specifically to the surface and prevents those bacteria from attaching, and then therefore prevents them from growing.
How do organofunctional silanes actually control the growth of odor in textiles?
Well, as I mentioned before, they provide an inhospitable surface for the bacteria to grow. What that means is, similar to humans, in order for us to survive and divide, we need four things. We need food, water, ideal temperatures, and a place to call home. When looking at the life and the use of a textile, little can be done about the textile becoming a good source of food and good source of water and ideal temperature. Food and water, humidity, is readily available from our body in the form of sweat. Ideal temperature for which bacteria grows, the same temperature of our body. So there's little we can do about that as well. But what we can control is creating a surface that the bacteria cannot survive. The quat silane, when reacted properly on the fabric, is a very harsh surface for bacteria. The technology has the ability to make a surface inhospitable, in which the bacteria cannot call home. Upon contact with the fabric, the bacterial membrane is immediately disrupted. A strong ionic charge and a large, long carbon chain component will interact with the bacterial membrane, which will immediately lose its integrity and be destroyed. The surface of the textile becomes completely unwelcoming to bacterial colonization, while the surrounding bacteria, the healthy ones that may be on our skin, are completely unaffected.
So what antimicrobial testing is most appropriate for those antimicrobial agents that happen to be organofunctional silanes? Why is that an important test to run for organofunctional silanes? In other words, how do organofunctional silanes differ in order to get that kind of a test?
Yeah, the test methods that we've used throughout the industry, they're really developed back in the 60s, and they were developed with the technologies that were available to us in the 60s. Many of those technologies were they were very toxic, they were pesticides, and they were leaching. Today's technology, like the quat silane, behave in a very different manner from those technologies that we used in the past, and they needed to be tested in a very specific manner. The textile industry has developed specific test methods and antimicrobials that are considered non-leaching, or in these cases, the metal-free ones. Quat silane technologies offer that unique approach at controlling bacterial growth on textiles, and they should be tested in a very specific manner. It was in 1987 that they developed the dynamic shake flask test, and that was developed specifically for these types of surfaces that are created, developing an inhospitable surface for bacteria, and those technologies don't leach from the surface. In 1995, these methods were established at ASTM, and in the year 2000, ASTM E2149 test method came out and is completely accepted by the committee. This test method has just been updated and most recently updated in 2000, and is the ASTM E2149-20. This is the test method that's recommended by the industry for measuring the performance of quat silane type surfaces.
Dr. Monticello, can you explain what the importance is of having companies test their textiles that are treated with antimicrobials at IAC certified laboratories and obtaining IAC verified test reports?
We specifically work with only International Antimicrobial Council or IAC certified labs, as we can be assured that those laboratories have the most experience in testing textiles with antimicrobial activity, and that these labs have been trained and tested on a yearly basis by the IAC. Antimicrobial testing is not trivial and is not common in many of the textile testing labs. These complicated tests must be performed by trained microbiologists, and the tests must be fully vetted in order to obtain the most reliable results. So false positive and false negative results can completely destroy a textile program, or at the very least significantly delay the program launch. Working with IEC certified labs and accepting only IEC verified test reports provides us with the confidence that the performance seen on our treated goods is correct, reproducible, and scientifically significant. And that's our promise to our consumers and our customers, is to receive the highest of quality.
Dr. Monticello, how can the International Antimicrobial Council support sanitized customers?
The International Antimicrobial Council is seen around the world not only as experts in the field of antimicrobial testing, but in the entire scope of antimicrobial treated articles. We support the mission of the IEC as a nonprofit NGO. They work to support the prudent and responsible use of antimicrobial agents. The IEC focuses on education of the industry in all aspects of antimicrobial and treated articles, from regulatory claims, labels, testing, to realistic end-use expectations. Their ability and their understanding of all the different antimicrobial agents on the market allows them to provide excellent guidance for any brand or retailer looking to provide an odor control feature. The IEC works with a variety of brands and retailers to customize quality assurance programs that uniquely fit their specific end-use expectations. The IEC works with many global suppliers of antimicrobial agents to make sure that they have the latest insight from the suppliers of how to measure these unique types of technologies. We're confident in the technologies that we provide, and we're confident in the guidance that we provide to our customers. The ISC can work directly with all of the sanitized customers to provide a full independent perspective of the antimicrobial industry. They can work to educate sanitized customers on the intricacies of antimicrobial testing and how this testing can be used to provide confidence to both sanitized customers and to their customers' customers. When testing treated textiles, the IAC will work with sanitized customers to provide lists of all IAC certified laboratories around the world that have proven their competency in providing reliable and reproducible antimicrobial test results. Working with the IAC both in development and during production allows for a very smooth program launch and continued success.
Is there anything specific that consumers should look for when they're looking at either odor controlling products, odor controlling athletic wear, or antimicrobial products that they're looking to utilize when they travel or work out?
I think it's really important to understand as much as you can about the technology that's being used. In many countries, you must actually state what type of technology is on the textile. And in many places around the U.S., you'll see the brands. And it's important that we add those brands on there.
If someone does buy an antimicrobial product, does it wear out? Does it kind of lose performance over time? And if so, how does that happen?
The way that we measure durability of antimicrobial agents on textiles is to simulate washings in the laboratory. The textile industry has several different ways in which we simulate these home launderings. AATCC 135 is one, and also the AATCC 61-2A is another methodology. Just recently, there's a new methodology that's come out from the ASTM E3515 committee that is specifically designed to measure the durability of antimicrobial textiles. So it's specifically designed to simulate launderings and then specifically test antimicrobial activity. That method is the ASTM E3162. And that's also coupled with specific rinse techniques that are proposed by the IAC M0600, in which we recommend both the ASTM E3162 and the rinse protocol to be used for all different treated quad-silane surfaces.
I'd like to thank Dr. Monticello for his time and for the answers that he's been able to provide for these questions. Should you have any questions, please feel free to contact Dr. Robert Monticello at ramphd@amcouncil.org. Thank you. Goodbye.